Yeah, hi. Imagine someone figures out the 500-year-old mystery and no one cares. Yeah, no one ever responded to that until now. More than a month, my paper came out and not one single response. But anyway, that's my paper, and let's just start here reading a little bit and then we go over to an article. Furthermore, it is known that Earth's axis is tilting every now and then about 90 degrees. And then, so it might be very well possible that Finland was once situated close to the equator where it's warmer and plants can grow naturally bigger through an almost constant season of growth. There is no reason why the Earth's axis couldn't or wouldn't tilt back. For example, the LLSVPs are in a way asymmetric and now situated at the proximity of the equator. They may have been once poles according to the stellar transformer concept. It would make a lot of sense since the main energy exchange of Earth is happening at the polar regions. Now to the article that's a few hours old or something. 14 February, 2 days old. Yeah, I just got it recently. But anyway, PhysDotOrg. Tilting of Earth's crust governed the flow of ancient megafloods. As ice sheets began melting at the end of the last ice age, a series of cataclysmic floods called the Missoula Megafloods scored the landscape of eastern Washington, carving long, deep channels and towering cliffs through an area now known as the Channeled Gaplands. They were among the largest known floods in Earth's history, and geologists struggling to reconstruct them have now identified a crucial factor governing their floods. Oh man. Now, in a study published February 14th in Proceedings of the National Academy of Sciences, researchers showed how the changing weight of the ice sheets would have caused the entire landscape to tilt, changing the course of the megafloods. People have been looking at high water marks and trying to reconstruct the size of these floods, but all of the estimates are based on looking at the present-day topography, said lead author Tamara Pico, assistant professor of Earth and Planetary Sciences at UC Santa Cruz. This paper shows that the Ice Age topography would have been different over broad scales due to the formation of Earth's crust by the weight of ice sheets. So this is obviously totally based on gravitational theory, Newtonian science. But anyway, let's continue reading. During the height of the last Ice Age, vast ice sheets covered much of North America. They began to melt after about 20,000 years ago, and the Missoula megafloods occurred between 18,000 and 15,500 years ago. Pico's team studied how the changing weight of the ice sheets during this period would have tilted the topography of eastern Washington, changing how much water would flow into different channels during the floods. Glacier Lake Missoula formed in western Montana when a lobe of the Cordilleran ice sheet dammed the Clark Fork Valley in the Idaho Panhandle, and meltwater built up behind the dam. Eventually, the water got so deep that the ice dam began to float, resulting in a glacial outburst flood. After enough water had been released, the ice dam resettled and the lake refilled. This process is thought to have been repeated dozens of times over a period of several thousand years. Downstream from Glacial Lake Missoula, the Columbia River was dammed by another ice lobe forming Glacial Lake Columbia. When Lake Missoula outburst, floods poured into Lake Columbia. The water spilled over to the south onto the west-eastern washing plateau, eroding the landscape and creating the channeled scablands. During this period, the deformation of the Earth's crust in response to the growing and shrinking of ice sheets would have changed the elevation of the topography by hundreds of meters, Pico said. Her team incorporated these changes into flood models to investigate how the tilting of the landscape would have changed the routing of the megafloods and their erosional power in different channels. We used flood models to predict the velocity of the water in the erosional power in each channel and compared that to what would be needed to erode basalt, the type of rock on that landscape, Pico said. They focused on two major channel systems, the Cheney Palouse and the Telford Crab Creek tracts. Their results showed that earlier floods would have eroded both tracts, but that in later floods the flow would have been concentrated in the Telford Crab Creek system. As the landscape tilted, it affected both where the water overflowed out of the Lake Columbia and how water flowed in the channels. But the most important effect was on the spillover in those two tracts. What's intriguing is that the topography isn't static, so we can't just look at the topography of today to reconstruct the past. I haven't read this. The findings provide a new perspective in this fascinating landscape, she said. Steep canyons hundreds of feet deep, dry falls and giant potholes, and ripple marks are among the many remarkable features etched into the landscape by the massive floods. When you are there in person, it's crazy to think about the scale of the floods needed to carve out these canyons, which are now dry. There are also huge dry waterfalls. It's a very striking landscape. She also noted that the oral histories of Native American tribes in this region include references to massive floods. Scientists were not the first people to look at this. People may even have been there to witness these floods. Yes. In addition to Pico, the co-authors include Scott David at Utah State University, Isaac Larson, and Karin Lechnik at the University of Massachusetts, Amherst, Alan Mix at Oregon State University, and Michael Lamb at the California Institute of Technology. This was it. So, landscape, floods. I bet there was water. And they are also thinking about Earth tilting over, like real scientists from many universities, really highly educated people. There was for sure water, groundwater rising up as the charge increases, like spheres within spheres within spheres. We have the magnetosphere, we have our atmospheric layers, and they're all held in place by electromagnetism. That's why we have an atmosphere in the first place. We have a magnetosphere, and we are all in that. So the groundwater is just another sphere. And if there's anything happening with the energy flow which goes through our planet, which connects us to the sun, and the sun is connected to the rest. So whatever happens out there, it will affect the sun, so it will affect Earth. We are somehow basically the last ones in this food chain. But anyway, if the charge is different or changes, fluctuates, the spheres grow or shrink, which means if the groundwater sphere, because it's quite It might be this kind of sphere, even though the boundaries might be a little bit vague. That's that it's in the ground. It's not a gaseous layer like we have in the atmosphere. But anyway, if that sphere is shrinking or growing, it might influence many things. Let's just imagine it would grow. What happens when the groundwater sphere grows? It will come out of the ground. In some places quicker, in some places a little bit slower. And if you're like in highly elevated places on mountains or something, probably you don't notice anything. But places like river deltas, the Po River Delta in northern Italy, it's flat like a pan, and it's not really elevated from the sea. So there is not much distance to the groundwater. And there are many volcanoes and hot springs and all these kind of things in the same area. So rhyolite magma or lava, which is basically the watery version of the red stuff which is coming out of many other volcanoes, based on water, silica, creates this kind of sandstone when it's dry. Yeah, and probably also these mountains, what we're looking at, if anybody has seen this Hyde, what was his forename? I don't remember. Benjamin Hyde, a former quantum mechanics dude, 25 years or something. He was studying quantum mechanics, then he found the electric universe, and yeah. He was there, and he came to the electric universe because he figured out that's the thing. So he was experimenting with baking soda and electricity, and he created these kinds of structures because they will rise up, meet here, and here what we have, this gravel stuff here is where the energy, the electromagnetic energy wasn't enough to fuse it together into a rock. That's why we have the gravel, but it got pulled towards it. Upwards, obviously. Some of it maybe tumbled down over the years, and they might be also like 6,000 years old and not millions of years old, or 12,000, whatever. But anyway, Earth is tilting over, also in mainstream science. Interesting. Thanks, bye.